climate change, a burning issue of our time. But what if there was a way to cool down our warming planet by using the very oceans that cover 70% of it? The rising temperatures, melting ice caps, and extreme weather events highlight the urgency of finding innovative solutions. Enter ocean fertilization, a method that could potentially harness the power of the sea to absorb more carbon dioxide. Imagine turning the vast oceans into a giant carbon sink. Sounds too good to be true? Let's dive a little deeper into this. Ocean fertilization involves stimulating the growth of tiny marine plants called phytoplankton that naturally absorb carbon dioxide. Now imagine this. We add nutrients like iron, nitrogen, or phosphorus to the ocean. This gives a boost to our microscopic friends, the phytoplankton. They party hard, grow in numbers, and in the process absorb more carbon dioxide from the atmosphere. This carbon then sinks to the deep ocean when the phytoplankton die, potentially locking it away for long periods. It's like a natural carbon storage unit, only wetter. However, science is never quite that simple. While there's evidence that this process can increase phytoplankton biomass in localized areas, the effectiveness of this method in sequestering carbon dioxide on a grand scale is still up for debate. The ocean is a complex ecosystem, and messing with it could have unintended consequences. Phytoplankton, the tiny plants with a potentially huge role in combating climate change. But how does this theory hold up in practice? In 2009, the LOHAFEX project set out to test the effectiveness of ocean fertilization in the Southern Ocean. The ambitious experiment involved sprinkling iron into the ocean's depths to stimulate phytoplankton growth, like a gardener tending to an underwater Eden. The results were intriguing. The fertilized area bloomed with phytoplankton, nature's little carbon vacuum cleaners, indicating that iron fertilization could indeed trigger biological productivity in certain ocean regions. But this scientific adventure wasn't without its share of controversy. Critics raised concerns about potential environmental risks and even violation of international agreements. They feared unintended consequences, such as disruption of marine food chains or oxygen depletion in deeper waters. Some even questioned the ethics of manipulating marine ecosystems on such a scale. Despite the controversy, the LOHAFEX project offered invaluable insights into the potential and pitfalls of ocean fertilization. It underscored the need for careful consideration, clear guidelines, and robust governance in such ventures. The LOHAFEX project, a scientific adventure with promising results but also a storm of controversy. So, where does this leave us with ocean fertilization? Is it a viable solution or a risky experiment? Well, the potential of ocean fertilization is intriguing. It could help sequester carbon dioxide, but it's not without its risks and uncertainties. It's like a puzzle with pieces still missing. We need more research to fully understand the ecological consequences. Robust governance frameworks and ethical considerations are crucial before we plunge into this deep-sea endeavor. As we grapple with the challenges of climate change, ocean fertilization presents a tantalizing possibility. But like all great scientific endeavors, it comes with its own set of questions and uncertainties.